Welcome to the next lecture, lecture number 2 on foundations of data science. In today's class or in today's lecture, what we'll be trying to understand is what are the process that is involved in data science. How do you prepare the data? How you convert the raw data into a meaningful data or how we are going to use it. Okay. So what are the steps that is involved? Where all we need to use it? What are the methods? So let me begin as usual with the outline of today's class. So we'll design or we'll begin our session with data science process. We'll try to know the definition of what is meant by prior knowledge, what is meant by business understanding, what are the steps involved in data science process, and detailed discussion in core steps, how you really create a data that can be really useful. Data cleaning, what is meant by data cleaning? Of course, yesterday we have given an introduction to handling missing values. Today we'll see slightly different more techniques. As far as problems are concerned, as I told you, what I prefer is that I will do a Python program in front of you and you will learn it. Okay? So that's the way where we are going to do our statistics. All the problem questions, I won't be teaching you how to do the problem. I will be writing a Python program to solve the problem. But in your exam, you have two parts, foundations of data science and data science lab. In data science lab, you have these programs, but in theory sessions, what happens is that you will be given some values and you will be asked to find out the answers. Okay? In theory classes, you will be given problems. I'll give you some examples today also. What is meant by outliner? How to detect outliners? And how to treat outliners. So outliners is a problem and how we are going to treat it is very important. How do you standardize data? What is Z score? How you calculate min max and so on. Okay. Then what is meant by EDA, exploratory data analysis? It's a very important subject and a special one which you will be learning in detail. You have a separate syllabus for this also. You have a separate professional elective for exploratory data analysis. In data science, we'll give an basic and what do you say, the simplest introduction to what is meant by EDA. We will not be going we'll not be going through in depth. We'll just have a basic outline. Okay, objectives of EDA. Then I'll give you some assignments and some review questions, and then we'll have some discussion on whatever we have learned. Okay, is that fine? So, what do you mean by prior knowledge? Prior knowledge refers to the domain expertise and existing understanding of the problem area before looking at the data. Prior knowledge means domain expertise. In the previous session, in lecture 1, I gave you an example of a patient and a doctor, right? A patient is approaching a doctor for some kind of diagnosis to understand what kind of disease a person is having. Okay. In that case, a data scientist or the person who is collecting the data should know what are the possible causes of a particular disease. That is known as domain expertise. Awareness or knowledge about the domain, the vertical in which you are expected to collect data. Every of my slide is a question in your exams, so I want you to be very attentive and take notes, and I don't want any murmuring there also. So what are the things that help, or why is that we need to have prior knowledge? We need to have prior knowledge because we need to design right hypothesis. So what is meant by hypothesis, I'll tell you later on, but you should understand that you have something called as hypothesis, right? Hypothesis. Say for example, certain diseases you need to know what is the age of the patient, whether the patient is a smoker or not, or you have any. See, for most of the things, whenever you go to a doctor, they ask you whether your parents are having a kind of disease. Say, for example, you go to a doctor to check diabetics, the first thing he asks you is that whether your father, mother, or anybody in your lineage had diabetics. So this is an input. Only if you know that certain diseases are hereditary, you need to go into that in depth. Okay. So next, this is called as a flow chart. Last class, in the first lecture, I explained to you what is an algorithm. Now this is a simple flow chart to make you understand the data science process. Okay. I told you most of the business establishments require a data scientist to analyze the data. I gave you an example of an automobile garage in the previous class. You have a garage where you service cars. So you should know that the capacity of the garage, how many cars can be handled, how many can be marketed, and so on. So that's an example of a requirement for a data scientist. Okay, so in that, whatever it is, even if it is a doctor, disease, you have some problem. That understanding is called as business understanding. Okay, this is business understanding. Understanding the problem, understanding how to find out a solution for a problem. Second thing is that data acquisition. Normally, what we do is that we collect all the information, data. Okay, we collect the entire information. This process is called as data acquisition. I believe that you know the word acquisition or what it means by acquisition. Collecting of data, preparing the data, making data ready for use, data exploration. Okay, see, when we collect raw data, we may collect infinite amount of data. Some things may be required, some things may not be required. Something may not affect your outcome. Suppose you wanted to do something, you are doing something to get a result, right? Say, for example, a patient is going to a doctor to get his disease diagnosed. Okay, so there might be some data Like what is his annual income? That is not at all related to his disease. Okay, this is called as feature selection, feature extraction, feature removal, and so on. We explore the data to find out whatever is really required for us. I told you only one simple example of having an irrelevant feature in our data set. There could be so many other things where we need to explore this data. Then what we do? Then we create models. Then we create models. That's called as modeling. And finally, we deploy that model so that our system gets automated. We deploy this model so that our system gets automated. So we have a loop because if something does not work properly, you go back to the previous stage, check whether all these things are okay, and then keep repeating it. Okay, this is a basic flowchart of data science process. Second thing, next thing, what we are learning today is what is meant by data preparation. Another word for data preparation is data wrangling. Suppose you are asked what is meant by data wrangling, don't get confused. Okay, it is nothing but data preparation for ease of understanding and for your ability to work out with. I have made it as simple as possible. So in data preparation, we have four important processes. We will be handling missing values. We'll detect outliners. But what is an outliner? I have not taught you. I'll be telling you in the next slide or in the coming slides. Okay. Outliner is a value that is totally different from the normal value. Okay. Suppose I am having a data set of your marks. Okay. I will be having marks ranging from 10 to 90, right? 99 or 100 is an outliner. 0 is an outliner. Or you have so many examples. Temperature, daily temperature you are analyzing, right? If it is more than 70 or 60 degrees C, there is something wrong in the data. That may not be a correct answer. In that case, you need to remove the outliners. You need to handle the outliners or you need to find out another means to overcome this. Okay. Feature engineering. I told you now what are features. The variables x1, x2, x3, xn. This is nothing but features. These features are the ones that is going to determine how useful your data set is going to be in the coming future. Data transformation. Data transformation means adjusting the values, creating a scaling, or making some codes. There are different methods of encoding a data. If time permits, in this course, we may extend our syllabus to learn how we encode our data. But it all depends upon the time and we have our basic limitations, right? What is meant by data exploration? I've already told you what is data exploration, right? How we are going to find out the different types of values in the data. So data exploration means initial investigation of data to discover patterns, spot anomalies, test hypotheses, and check assumptions. These are the points you can underline in your exams when you write the answers, which can fetch you more marks. Using summary statistics and visualizations. The objectives of data exploration is that first thing is that you need to understand the distribution of variables, how it works. If there is no correlation or if the variables are totally indifferent, we can have another way of doing things. Identify the relationship between variables. Detect outliers and errors. Detect outliers and errors. Formulate hypothesis for modeling. In general, for data exploration, we use pandas library in Python. We use R programming language. We can use Tableau. We can use Excel and so on. Okay. Now, what is hypothesis? Can anybody tell me what do you mean by hypothesis? You understand that? Hypothesis is a statement that is going to give you a conclusion. Say, for example, I'm giving an analysis of the marks of my students in foundations of data science in the first internal exams that is going to be conducted. Okay. An hypothesis can be a statement like this. My students, 60% or above of my students will have more than 80% marks. Okay. This is a hypothesis. The statement is a hypothesis. The hypothesis can be proved either right or wrong. Okay. In detail about what is hypothesis and how to formulate hypothesis. Formulating hypothesis is an extremely important process, and that requires a lot of energy and understanding of the data set to formulate a hypothesis. So this is a simple way in which I've told you that we have something called as hypothesis. Hypothesis is a statement that is going to assert something, that is going to give us something, that this value is going to be like this. Okay. Whenever you read, you might see that. Okay. In newspapers and in other, maybe in articles and so many other places, you might see that 60% of the people visiting in this place is this one. Okay, so much number of tourists are visiting here. So all these things are hypotheses. Hypothesis is a statement, okay, that is expected to be true, but can also turn out to be false. Okay, doesn't mean that every hypothesis that is being formulated really is there. Next, we'll be learning about data cleansing. So is a first step, is a critical first step to make sure that high quality data, high quality analysis is available. That means you know that the probability values are always between 0 to 1, right? If at all you have a value which is more than 1 or below 0, you know that it is an invalid probability, right? All of you. So if you have a value more than 1, what do you say? That's a wrong one, right? Same way you have marks from 0 to 100. If I give somebody 105 out of 100, what do you say? It's a wrong data. I cannot give below 0 also, right? So we need to clean data. That means we need to understand that a data can be only in a way that can be used. Okay. So missing data can arise. So we need a clean data that leads to a better prediction. Okay. The points that I am highlighting here are the things that you can underline in your exams, which can help you fetch more marks. So missing data can arise from survey responses or equipment failure and so on. You have an automatic equipment, say like a webcam, to detect the number of vehicles passing through this national highway. Suppose you have a power failure for a minute or two. What happens is that the camera gets switched off. The data is missing, so missing value. That's what is called as equipment failure. That is one of the reasons why some data may be missing. Sometimes you may have the same data recorded more than once. Duplicate records. Outliners. Inconsistent formatting. So how do we handle this kind of problems? Ignoring the tuple, deleting the record, but that's like handling the missing data the same way. First thing is that you remove the data, that's enough. The data is missing actually, okay? Now, another way of doing it is that going through all the data and finding out and putting a manually most suitable data. I'm checking through all your marks. I didn't find one student's mark. I'll call the student, I'll check what is his mark and then I'll enter it. This is what is manually entering the missing data. But this is time consuming, but what happens is that, it gives us the exact value, right? Accuracy is higher. I have a data set of all your marks. One or two students' mark is missing. What I can do is that I can call the student, can check the mark and then enter the mark. So this way, what I'm doing is that I'm filling it manually, and it's one of the solutions what we do when we have missing data or inconsistent data. Mean median imputation, replacing it with average value or with the median value, or keeping a standard fixed value, right? I'll teach you about different kinds of functions, activation functions. So many functions are there. Okay. So when I go on with these classes, I'll teach you how we use that. We can make a function which can find out the missing value and replace it with that one, right? That's another way. And I told you about the regression or machine learning methods to predict the missing values. But always we have to remember the way in which we have filled in the missing values. Because if the model gives us an inconsistent value or something that is not possible in the real sense, okay, some values that do not match our common sense, we need to go and correct the missing values. Is that over? Very important and a very standard question, mostly coming to your examination point of view. Define outliners. Outliners are the data points that deviate significantly from other observations in a data set or from the established norm. They can result from measurement errors or inherent variability within the data. Okay, I can give you an example. Say I have certain values like this 3, comma 4, comma 7, comma 2, comma 89. This value, that 89, is an outliner. Okay, this 3, 4, 7, 2 and all fall within a small range, but 89 is something that is totally different from the rest of the values. So an outliner is a numerical value that is totally different or totally different from the existing set of values. What happens is that if you are replacing a missing value with an average, this 89 will affect the entire average, will make the things change completely. So outliners are very important and we need to handle these outliners. Okay, this is the way we handle. So how does outliners occur? Sometimes you may get a question about how does outliners occur. Measurement errors, data entry typos. Sometimes we have a genuinely original extreme values. Okay, how do we correct? One method is called as z-score. I'll tell you how to find out z-score in the coming slides. IQR method, visualization, creating graphs, creating plots. I told you now we are using some kind of functions. We can use some kind of functions to treat the outliners. And the simplest and most easiest way is to remove that outliner from the data set. Simply exclude that data or isolate for investigation. Okay? But that's not the ideal way whenever you have a genuine extreme cases. What you can do is that you can remove the outliners, but what happens is that if it is a genuine case, then what will happen is that you will have some errors in your model after you have given your data. What is meant by z-score? Write fast. So how to calculate z-score? Z-score is nothing but the individual data point minus the average by the standard deviation. Do you know how to calculate standard deviation? Before I begin my lectures, I told you you have to revise your statistics and basics of mathematics, whatever you have studied previously. Okay. So z-score is nothing but the value, that point, data point, minus the average divided by the standard deviation. Okay, and if the set score is greater than 3 or less than minus 3, it is considered as an outliner. This is a way, one method of finding out what is an outliner. You have a set of data points. In the set of data points, you wanted to find out an outliner. You need to use certain statistical methods, and one such method is called as z-score. Z-score is otherwise known as standard score. Standard score is a value at that particular data point minus the average divided by the standard deviation. So Z-score standardizes features to have mean 0 and standard deviation 1. Based on the set score of an individual data point, we can come into a conclusion whether that particular data point is an outliner or not. Is that over? I'll give you an example. You have values 50, 60, 65, 70, 75, 80, 85, 90, 95, 100. I want you to find out the z-score for the value of 55. That is this first value, x is equal to 55. How you will do that? First you will find the average of all these values. Average means this one plus this one plus this one plus this one. All the values are adding divided by the number of values, that is 10. So the average of these set of values, we got it as 77.5. Okay. Now how you will find out the standard deviation, sigma? It's very easy. Xi, 55 minus 55, the whole square by 10. Okay. Minus, that is the sum of the square of the sum of the differences between individual data points with respect to the mean, the whole square divided by the number of values, square root. Okay. Have you all noted this down? So what you are doing is that 55 minus 77.5, the whole square, 60 minus 77.5, the whole square, like that you are adding it and dividing it by 10. Okay. So you get the average value, the standard deviation to be 14.36. After you have done this much, it's very easy. This is the formula. The set score of 55 will be 55 minus the average value, that is 77.75 by 14.36. You got it as minus 1.57. So conclusion is that I told you the Z value, Z score is greater than 3 or less than minus 3, you can take it as an outliner. Here you got it as minus 1.57. So what will be the conclusion? It is not an outliner. I hope everybody understood this, right? Is there anybody in this class who did not understand how to find the Z score of a data set, you can please raise your hands. I will repeat it again till you understand. Is there anybody who did not understand? It's quite simple, right? The only thing you might have forgotten would be to find out the standard deviation. Okay, that's very easy. X minus mu the whole square. Okay, the value at each data point minus the mu the whole square. So why do we want to standardize data? Why do we want to detect the outliers? Why do we want to standardize this data? Why do we want to create a normal values? This could also be a question in your exams. There might be certain features or certain things which might really affect the total data set completely, right? Okay, some values, okay, for an for example for age and all these things. So what we do is that one another way of treating is to normalize this entire data set, create some kind of formulas. One min like Z score, another way of doing it is that it's called as min max formula, where if the x is a normal value, then you have this x minus minimum, the least value by maximum minus minimum, so that we change the whole data set. Shall I go to the next? Because we are running short of time. What is meant by data integration? Definition. Data integration involves combining data from multiple heterogeneous sources to create a unified view. What is meant by data integration? So what is meant by data integration? Integrating data is very important because we need to draw proper conclusions. Okay. Next is a very important definition. What is meant by exploratory data analysis? EDA is to gain deeper understanding of the data set. Okay, we have a data set, we need to understand in depth the meaning of each of these values. I told you yesterday, while giving this example of going to a movie or not going to a movie, you wanted to make a decision of whether you want to go to a movie or not. You are collecting some data for that. In that, if you have one particular data, say for example, you have an emergency in your hospital, somebody is admitted. So means going to the movie is completely ruled out, right? So that particular feature of the entire data set might be extremely important, and that alone can decide whether you are going or not. You understood? All of you? So that in order to understand that, you need to do data exploration. Okay, you need to explore you need to have something called as exploratory data analysis. So based on this only we generate this hypothesis. Okay, we have this. The reason why we wanted to do this exploratory data analysis is that we need to profile the data. Profile the data means we need to know what will be the maximum values, what will be the minimum values, what is the range with which you are going to process the data, and all these things. Clear? Then we need to select the variables, identify whichever features are relevant for us, which is important for us. Diagnostics. You need to come into a conclusion whether this will work out or not, or whatever is the thing that you are planning to do is going to be feasible or not. We have to be basically feasibility study, and all those things requires the data set to be explored, okay, in such a way that it can be used. So basically I'm concluding today's class with this point. But I'll be giving you some homework and practice problems which you need to complete and submit it in your Google Classrooms. Okay, I've already sent the link for Google Classrooms, and I've posted the syllabus and other materials for Google Classrooms. Now I want you to write down these questions, complete it and submit it by say Monday in your Google Classrooms. Clear? Is that clear? So you can write down the questions very fast. So I'm giving you for some time so that does not move away very fast, so that you can write down all these things. Okay, these are your questions for your assignment 1. So today, these are the important things that we have seen or we have understood. What is data science process? How to prepare data? What are the different ways of handling missing values? What is meant by an outlier? How to find out z-score? The formula for z-score. It should be in your mind. What is data integration, what is exploratory data analysis. So if you have any questions or you want to interact with me, you can do that. I can answer all your queries or questions. Any questions? So thank you all, thank you very much for attending this session.